Imagine building a house in space, not on the moon, not on Mars, but floating 250 miles above Earth, orbiting at 17,500 miles per hour. That's what humanity did when they built the International Space Station, the ISS. It's one of the greatest engineering projects ever attempted, and it took decades of planning, thousands of scientists, and an unbelievable level of cooperation between countries that were once enemies. The story of the ISS begins long before the first module ever launched. It starts during the Cold War, when the United States and the Soviet Union were racing to space. Both sides built their own space stations. The Soviets had the Mir, and the Americans had Sky. Each one proved that humans could live in space for extended periods, but they were limited, short-lived, and belonged to single nations. The dream of something bigger was already in people's minds, a station where the world could work together. After the Cold War ended, that dream became possible. In the early 1990s, the United States, Russia, Japan, Canada, and countries across Europe decided to join forces. They signed agreements to build something humanity had never seen before, a permanently inhabited outpost in space. The plan was to combine experience, money, and technology from all around the globe. The result would become the International Space Station. But saying you'll build a space station and actually building it are two completely different things. The ISS wasn't built all at once. It was built piece by piece, like assembling a massive Lego set, except every piece had to be launched into orbit by a rocket. Each part had to fit perfectly, align precisely, and connect in zero gravity. The first piece of the puzzle was launched by Russia in 1998. It was called Zarya, which means sunrise. It provided power and propulsion for the early station. A few weeks later, the United States launched the Unity module, which connected to Zarya in orbit. That connection was more than physical. It was symbolic. It showed that nations that once competed in the space race could now work together to build something bigger than any one country. From there, more modules were added over time. Laboratories, living quarters, airlocks, solar arrays, and robotic arms. Each one came from a different country, built with different technologies, yet designed to fit together perfectly. It was a global puzzle floating above the Earth. NASA's Space Shuttle played a huge role. The shuttle could carry heavy modules and astronauts at the same time. Every mission added new parts, sometimes as large as school buses. Astronauts used robotic arms to carefully lift each module out of the shuttle bay and attach it to the growing structure. It was like a delicate ballet in space. One mistake, and millions of dollars of equipment could be lost. The solar arrays were some of the most impressive parts ever installed. They unfolded like giant wings, stretching more than 240 feet across, wider than a Boeing 777. They turned sunlight into power, keeping the station alive. Each array had to be deployed perfectly, and even a single jam could have been disastrous. Inside the station, things were no less complicated. Every module was filled with systems oxygen recyclers, carbon dioxide scrubbers, temperature controls, computers, and water filters. The ISS doesn't just float, it works like a small planet. It recycles almost everything, because resupply from Earth is expensive and limited. Water used for drinking might later be used for cooling or even turned back into breathable oxygen. By the early 2000s, the ISS had grown large enough to house a permanent crew. Since November 2000, astronauts have been living there continuously more than 2 decades without a single empty day. That means every sunrise and sunset, every experiment, every meal eaten in microgravity has been part of a continuous human presence in space. Humanity has never been so far from home for so long. The construction process wasn't easy. There were setbacks, accidents, funding issues, and political tensions, but the will to continue never died. The ISS became not just a laboratory, but a symbol of what humans can do when they put differences aside. Americans, Russians, Europeans, Canadians, and Japanese astronauts live together, work together, and even share meals, all in zero gravity. Inside, the station looks like a maze of wires, screens, and equipment. There's no up or down, because in space, direction doesn't matter. Astronauts float everywhere, sleeping in small cabins strapped to walls so they don't drift away. They eat special space food, exercise daily to prevent muscle loss, and work on hundreds of experiments that help us understand everything from human biology to climate change. One of the station's main goals is research. It has a laboratory like no other. Scientists study how plants grow in microgravity, how human bodies change without gravity, and how materials behave in space. Every bit of data helps us prepare for the next big step, returning to the moon and eventually reaching Mars. But the ISS isn't just about science, it's also about cooperation. More than 15 countries have contributed to it. Each module carries a piece of their technology, culture, and pride. The Japanese built the Kibo laboratory. The Europeans built Columbus. The Russians provided crucial life support systems. And the Canadians built the famous robotic arm, the Canadarm2, used for moving cargo and helping astronauts during Over time, the ISS has become a floating city, larger than a football field, weighing nearly 420,000 kilos. It circles the Earth every 90 minutes, meaning astronauts see about 16 sunrises and sunsets every day. From up there they can see the thin blue line of Earth. It's the atmosphere, a reminder of how fragile our planet really is. As the years passed, the ISS faced challenges. Systems wore out. Solar panels degraded, and space debris became a growing